Okay, good morning everyone. Very welcome to this session on multidisciplinary engineering on the 3DEXPERIENCE platform. Very excited to be here today together with my two colleagues from UK and Sweden. So my name is Johannes Storvik, I'm based in Oslo and I'm CTO at Technia. Amit?
Yep, so I'm Amit Patel, I'm Technical Customer Care here in Technia UK.
I'm Thomas Gisén, I'm the Nordic Sales Manager for Installation Products based in Gothenburg.
Great, guys. So we will take you through this session together, but to set the scene a bit, this is obviously an event that focuses on the automotive industry and the huge transition that is happening at the moment. And Amit, would you like to say a few words about what is happening on the, especially on the electronics side?
Yeah, so as we see in the current global climate, everything is moving electrical. So I think the UK has an aim by 2030 to remove, remove emissions from all vehicles. So all vehicle platforms are removing the internal combustion engine, so the ICE, and moving more to an electrical based platform, so fully electric.
Excellent. And Thomas, what does that mean in terms of electromagnetic challenges?
Yeah, there are huge challenges, of course, to do optimization of all those systems. And as you can see, there are a huge number of ECUs and the lines of cables and multiple antennas in the vehicles today. It has to be in some way simulated and also to be optimized in a good way early in the design phase. So that's what we're going to talk about today.
And the complexity is growing by each generation of platforms and vehicles, right? And on top of all this advanced hardware, there's of course a huge amount of software running, both for entertainment purposes, but also to control the vehicle and also moving towards autonomous drive. So what we see today is that many vehicles start to contain hundreds of millions of lines of code, and that is growing for each new feature that is added to the car. So let's leave that as an introduction for the topics that we are going to address today. And the main topics that we want to share with you today is, first, I'm going to share some insights to how software can be managed in a PLM and ALM context. Then Thomas, you will tell us a bit about the electromagnetic simulation.
Yep.
And Amit is going to walk us through electrical engineering and all these challenges related to harnesses and PCBs and everything related to that. So I think without any further delay, let's get started. Okay then. Let's continue with the first topic that we would like to talk about today, and that is in the context of integrated software development. Already mentioning that software is now increasingly becoming a hugely important part of all vehicle development. If you look a bit from an historical perspective, of course, in the past, to develop a new car was a lot about managing the mechanical development and managing all the parts, physical parts that make up a car. Of course, that is still relevant, but it's relatively losing its importance compared to the electronics development and also the software development. As I said, we see an exponential growth in support systems that a modern car has, the entertainment systems, but also now the development towards autonomous drive. A typical car today is starting to approach some 200 million lines of code. A few years into the future, many analysts think that the total amount of code will start to approach 1 billion lines of code. So it's quite clear that managing the software development is becoming one of the key disciplines to master in automotive development. And this, of course, has to be aligned with the hardware, the mechanical development in the best possible way. if you look at some statements from major OEMs like Volkswagen, they estimate that today some 10% of the cost and the effort of developing a new car is related to software. They estimate that to within the next 10 years to grow to 50%. So the importance and the effort and the complexity of software management is going to be increasingly important to master moving forward. So linking that to the topic of the day, product lifecycle management, and how this can be integrated and managed using modern computer systems. The 3DEXPERIENCE platform from Dassault that we are mainly working with in terms of managing the development of cars and any other products is pitched around a digital definition of the product. And to be able to establish that digital product definition, you have to be able to integrate models covering all disciplines. So today we are touching on simulation, on electronic design, and on software. All of that information is brought together into what we call a unified product structure that represents the product and carries all information that is needed to design and to describe this product to the tiniest level of detail. And in this shift going from more document-based ways of documenting and working, we now see a big transition towards more model-based ways of working, which means that a PLM system, PLM platform needs to be able to manage models coming from all these different domains. So in this first presentation, I'm mainly going to focus on how the software aspect is managed. And software is, of course, even if that's not a physical thing, it's still something that is part of the definition of the product, which also needs to be managed in line with the more traditional geometries and the harnesses and everything that makes up the definition of the car. So from a 3DEXPERIENCE point of view, you always have this product structure that represents the car. In this example, an ECU, and the ECU, of course, contains both of mechanical components, of electronics, and software that is running on that unit. So in 3DEXPERIENCE, we have a notion of software items, and with the quite new role and capability called software engineer, you are able to link the actual code and keep track of the version management directly as items in the product structure, meaning that you have the same level of configuration control, version control, and visibility of which version of the software goes with which version of the hardware. You can even establish and maintain links to external code repositories. So the actual code will normally not be on the 3DEXPERIENCE platform itself, but it will be linked there from external software code management, configuration management systems like Git. But for full visibility of all across all disciplines and all members of the engineering teams. When talking about software and software development, we also get into a territory where the actual development processes are a bit different from the traditional mechanical and electronics development. So even though there are many similarities between PLM and ALM for application lifecycle management, there are also a number of differences. And maybe the most important one is that software is usually developed in a much more agile and iterative fashion, meaning that the tools and the processes to support that kind of development needs to be aligned with that. While PLM, working with physical items and physical product development, need to take care of some of the physical realities like lead time for parts and the complexity of setting up a supply chain and so on, meaning that the agility, it can still be agile, but you still have to account for time constraints and lead times and all these restrictions that exist in the physical world. A consequence of that is that what we see among car manufacturers and suppliers to the same is that they prefer to still use specialized tools for software development that is better aligned to support the agile processes and the established way of working within software development. And that often leads to companies using multiple platforms to manage different parts of the product information. So as an example, and this is also based on our own experience with the same, we see many companies using 3DEXPERIENCE to collect and manage and keep kind of the master definition of the product, while the actual software development and many activities that is related to that happens inside tools like ALM tools like Jira, where you have predefined working processes that is aligned with the way that typical software development teams work. In our experience, these two worlds, to use that term, are usually quite disconnected. So even if you are working on developing the same product, this software is going to end up inside the car. A lot of the development is still happening in a quite siloed environment, using different platforms and following different processes. What we see is a great, because of this growing importance of software, we see a very quickly growing need for providing a better and tighter connection between these two worlds. So not only integrating the result of the design process, like the code I showed in the previous example, but also to make sure that there is a continuous interaction and a seamless collaboration between the two. So what we have done to mitigate that issue is that we have developed a connector that brings 3DEXPERIENCE close together with Jira, allowing information to flow seamlessly between the two and allowing our customers to use each tool, each platform for the purpose that it's best fitted for. So to show you or explain some examples of what you can do in 3DEXPERIENCE, like we have already mentioned, you have your engineering items that are organized into product structures. That is the kind of the main carrier of information. Related to that, you have a number of different artifacts and processes that represents different activities that have to take place during development. It could be the change management, it could be requirement management, ad hoc or planned task management, and keeping track of issues, as some examples of what you typically would take care of using a PLM platform. And some of these same needs and concepts also exists in the ALM world, but in that world you usually use different terms. And in Jira, for instance, everything is concentrated around different types of issues that you use to organize and plan your work, typically as epics, as stories, as tasks, and as bugs to keep track of anything that needs to be fixed. Using our 3DEXPERIENCE to Jira connector, you can easily build a mapping between your information models and processes that you work with on either side. So as an example, you might want to map your change actions into epics, your requirements into stories, tasks could as in this example, be task that is something that exists in both systems, and then issue identified in 3DEXPERIENCE might become a bug in Jira. But we support a full flexibility so that you as a customer can map whatever information item into any information item in the other system. So to show you an example, starting with issue management. What we see here is that in 3DEXPERIENCE, we have the same examples that we saw before, the ECU that contains of hardware components and also software items. In this case, there is an issue identified. There's a problem with this unit, and it's not yet clear what is the cause of this issue. So it's raised again the end item, the complete ECU with all its with the full product definition. After some investigation, it is concluded that this is an issue that has something to do with the software. It's not a hardware issue. So you want it to be resolved by the software engineering team working in Jira. So as soon as the issue is properly described, you will initiate this process, and the issue will then automatically be replicated as a bug into Jira. On the Jira side, the software team will start investigating and mitigating, fixing this bug and correcting the software code. Probably creating subtasks and plan and execute their work as they normally do inside of Jira. As soon as the job is done, it will be reflected in the workflow in Jira, and a signal will be sent back to 3DEXPERIENCE that now this job is now complete, and the issue can be closed. And then we'll ensure you that you have a closed loop traceability all the way from issue identified until the problem has been solved and the new version of the code has been integrated into the product. So what does this look like in real life? So what we see here is an example where we have 3DEXPERIENCE to the left and Jira to the right. Using the standard user interface. So to do by running through the exact same process again, what you would do from the 3DEXPERIENCE side is that you start by creating an issue where you would typically describe and categorize the problem. What is the issue? How critical is it? And so on. Capture all the details. Then you would link it to the product or item where the problem has been identified, and you might want to add some supporting documentation. Could be screenshots, images, any other documentation that explains in more detail what the issue is about. So what will now happen in the background as soon as you start the workflow is that the issue will be by the connector will be sent to Jira. And in that case, it will quite more or less instantaneously show up in the inbox of the software engineer that is working on that issue. And you can see that some of this key information, key metadata, is now replicated across. You can also see the workflow. The attachment and the images have been added, and it's even possible to using a hyperlink. You can go back to 3DEXPERIENCE directly from Jira if you have the proper license to do so. So that is one example of how you can use the integration to tie together the workflows and the processes from the PLM side to the ALM and Jira side. Another quite common example is requirement management. We have many customers who do all their requirement definition in 3DEXPERIENCE using the requirement management module. And in 3DEXPERIENCE, requirements are managed as individual objects. They are kept together as a requirement specification, but each requirement is an individual object that can be linked to the product or parts that they describe. So if there are requirements then that will end up as software features, you typically want to bring that information in a convenient way to the software engineering team. And that is what is shown on this picture, that in a similar way as with issues, we can publish the requirements into Jira, and they will show up as stories, for instance. So we could consider the requirement specification to be an epic, and then manage each individual requirement as a story that needs to be implemented. And on the Jira side, you can then use all the normal functionality to break this further down into individual tasks and activities. And then, of course, the end result of this development would be a piece of code that you would then link back into the product structure as a software item. This is what it would typically look like. So in this case, you have the requirement management module in 3DEXPERIENCE to the left, and you have Jira to the right. So as soon as a requirement is ready to be processed, it will be sent from private to in-work, and that will then automatically make it available in Jira. So this is an example of what it would look like. And like in the issue example, you can see that the detailed properties of the requirement, it also includes not shown on this picture, but it also includes any rich text, images, any more detailed description of the requirement. But all the key properties, the life cycle state is then brought across to Jira, so that the software engineers can then easily access the information they need to start their work and feedback on the status and progress on implementing and fulfilling this requirement. And related to that, another area that we support is, of course, also the test management to verify and validate that the software requirement has been properly implemented and that the requirement is met. There are also many other examples, but for this session, we'll stick to these two. So to summarize a bit, some of the key takeaways: by using our 3DEXPERIENCE to Jira connector to bring these two platforms together, you can still ensure a seamless collaboration between the different teams, even if they are working on different platforms. You also ensure and extend the digital continuity that is established by the 3DEXPERIENCE platform, all the way from requirement to manufactured product, also including, in this case, the software engineering activities. Sorry. Since this is a ready-made product, which is configurable, we can assure a very short time to value. You don't need to develop any code yourself or to develop the integration. It can be configured directly based on your specific business needs. And it is based on top of a very proven technology, our integration framework that we have developed since 15 years, that have been widely used across the industry to support all other types of enterprise integrations like ERP and CRM and others. But in this case, then specifically adapted to support efficient collaboration between 3DEXPERIENCE and Jira. So that's all from my side. Let's move on to the next session, where Amit will talk us through the electrical engineering aspects of multidisciplinary collaboration. Thank you.
So, hi guys, so I'm Amit Patel. We'll be looking at the electrical engineering aspect in 3DEXPERIENCE. So where are we currently? So currently with vehicle platforms, we're still using an ICE, an internal combustion engine. You probably noticed if you look around you, go to car showrooms, there is more and more hybrid vehicles, and especially primarily electrical vehicles coming into the market. Now, they say currently the wire harness is the third most expensive component in the car after the motor and the chassis. So we're probably not even talking about today, we're talking about yesterday. So today we're probably looking at anywhere between 35 and 40% of a vehicle's cost is the electrical component in the vehicle itself. Okay? And these figures have been conducted by Cohen's research. It's predicted by 2030 that the complete electrical cost to a vehicle will be about 50%. So this is eliminating the ICE, the electrical engine, internal combustion engine, and replacing it with electric motors and the wheels and so on. So what a lot of these automotive manufacturers are currently doing at the moment. Okay, so the cost of electrical components are continuously going up and up as new vehicle platforms get developed. So what I'm going to introduce you guys to is how 3DEXPERIENCE, or how you can leverage the use of the 3DEXPERIENCE platform to help you design an electric vehicle. So the overall process would be, so outside of 3DEXPERIENCE, perhaps you might leverage some parts of the platform to help you with some of the preliminary aspects of the electrical vehicle design. Is the specification planning. So what is the actual requirement? So perhaps you may decide that the first requirement will be, hey, I want an electric vehicle. How many motors? Does it need to be all-wheel drive, front-wheel drive, rear-wheel drive? How is it going to be controlled? What's the range, etc., etc. So all of that information, you may use other aspects of a 3DEXPERIENCE platform to capture them requirements. You then have system architect diagrams and a control architect diagram. So where you kind of determine what components you need and how they would affect one another. So perhaps you may have a radar sensor at the front of a car, and that needs to communicate with a controller which controls the motor speed. So as it might approach a distance, coming up to maybe a vehicle in front, the radar might tell the vehicle to slow down, so reduce the power to the motors, etc. So you'd set all that up sort of in your system architecture. Once you have all that defined, this is where 3DEXPERIENCE comes into itself. So you'd either go down two routes, and it doesn't matter which two you go down, you can bring them together collaboratively. So typically you would go down the 2D schematic route. So you would create a schematic of how everything is going to be laid out and how everything will talk to one another. So what pin will communicate with what pin on a different controller or a sensor, how one sensor feeds into another sensor, etc. So all of that is drawn out in your 2D schematic. You could go down another route where you just go straight into 3D design. So where you place components in, work out where they need to be, and then kind of route your harness afterwards and just say, well, I know that this needs to be connected to this via a cable which goes from A to B. However, nothing will ever in a car usually go in line of sight, and there's lots of obstacles. So you would have to have basically go for a maze of trying to route your electrical harness. Okay. At that point, we've basically just said there's one large connector connected to, so one large cable connecting two devices. So it doesn't really know any pin information. So once we've got our schematic, we can, in 3DEXPERIENCE, feed that back into our 3D design. And what that will tell us is how the individual wires inside a cable communicate to different components within your electrical infrastructure. Then finally, what we tend to do is take all that information and help us actually manufacture the harness. So there's no point doing all these fancy designs in 3DEXPERIENCE, but you have no idea the length of a cable when it's laid completely flat, or how you're going to actually manufacture it. So what you can do is use something called harness form board to do a layup of how that will be manufactured. So pin diagram. And then also with manufacturing drawings and reporting as well. So yeah, you can do that as well. And you can take your harness form board into process planning. So what we'll do now is just have a look at what we can do with 3DEXPERIENCE. So I'll talk over some of these videos. So what we'll start beginning with is the schematic designer. So in 3DEXPERIENCE, you are able to actually create a schematic. This wasn't previously available prior to 3DEXPERIENCE being made available, but in 3DEXPERIENCE platform, this is something that we can now leverage the capability of. So what you would tend to have is individual components stored in a catalog. So to make everything easy going forward, you would spend time initially doing the setup. So you can see here on the screen, currently we are taking connectors which have been previously defined, stored in a catalog and reused in the schematic that we're having a look at now. The reason for that is generally for electrical design, you're reusing components. You're not generating or creating new components. You would go to a manufacturer of a component and you would store that information in your catalog to reuse later. What is unique in different electrical infrastructures is the routing and how one component may communicate with another, but the end components are typically reused. So in this case, we have a bunch of connectors, control modules, and what we're doing is basically routing the individual wires from each pin from connectors and telling 3DEXPERIENCE what connects to what. So where is A, where is B? Okay. Eventually what we'll have a full infrastructure diagram. Okay. And what we've told it is the size of each wire, and we can give the wires a unique identifier as well. So we know what wire communicates with what, etc., and which pin it goes from one controller to perhaps a sensor, etc. And you can see from the screen is literally just drag and drop. So you click on one component where it starts and click on another, so where it stops. Once we've designed that in the schematic, we can take that and feed that into our 3D. Okay, so what we would have done is taken that information and we can use that to drive how our 3D wire thicknesses are laid in the vehicle itself. So if we move on to our next slide, what we would typically do in our 3D now is create our library. So we looked at creating a library for our schematic. However, we still need a 3D representation for the CAD. Now, as I mentioned, all of these components are usually purchased off-the-shelf components. So there are some suppliers that you can purchase these from, and you would download these components. So wouldn't design them yourself, but unfortunately, currently, as we stand, there are no electrified standard parts. So there's electrical standard parts which you can download, but they are just dumb solid models typically. I think the ISO standard step files are looking for a way to unify that. However, we're not quite there yet. So what we will typically do is download these models from a manufacturer, import them into our 3DEXPERIENCE session. So there'll be like an ISO standard file type, like a step, and we would build our library. So we wouldn't do this on a need by need basis. We wouldn't think, oh, in this particular harness, I need this connector today. You would look at your complete arsenal of connectors and think, I use all of these connectors from this particular manufacturer. I use these connectors from this other manufacturer, and I will take the time to build my library inside 3DEXPERIENCE. Now, before we build our library, so we can see here, once we've imported the dumb solid, we have to electrify it. So we have to tell 3DEXPERIENCE how it behaves electrically. So we'll define how many pins it has, where the bundle connects to the connector on the back, how it may connect to a back shell. So what will happen later on, once we have it in a catalog, we would literally be able to say, this back shell needs to connect to this connector, and everything will just connect and align as required. To get the alignment correct, what we do in 3DEXPERIENCE is actually make use of axis systems. So in this particular case, we are using axis systems. Now, I've talked a lot about connectors. We aren't restricted to just connectors itself either. So we can use other electrical components such as supports and retainer clips, etc., etc. If you have, let's say, a control module that you want to electrify and place connectors inside that control module, we can electrify the control module as well. Okay. And the benefit of the 3DEXPERIENCE platform, we can also remove electrical behavior. So if we've accidentally electrified a CAD object that didn't need to be electrified, we can remove that particular behavior as well. Okay. From here as well, we can also create protection. So protect any protective sleeving that you would use to build your harness or heat shrink, you can define that in here as well. Okay. So eventually what we will do is, with our support here, we would take all this information and compile a catalog that we can reuse. So having built our library up of the electrical standard parts that we'll be using, and then having given them electrical definition inside 3DEXPERIENCE, we essentially, the next step is to place the components. So where will they be placed? So we would know from the rest of the CAD. So you might have, let's take the example of a car door. You would particularly know where the connectors would be as a rough estimate. You'd place those connectors in those positions and then create a wire route harness. So if we have a look at that. Now, the benefit of using 3DEXPERIENCE Electrical is if someone suddenly changes perhaps part of a structure and it's now clashing with your connector or your routing, it's very quick and easy to just move a connector or add more control points to reroute your harness around the obstacle. You can also use the obstacle tool in 3DEXPERIENCE, which will allow you to automatically avoid other objects. So what we're doing here now in 3DEXPERIENCE, we're actually creating an electrical assembly. Now this is different to a CAD assembly because we're actually telling 3DEXPERIENCE that it's electrified. And all we're doing is taking connectors from our catalog. So these connectors that we downloaded from our manufacturers and then electrified in 3DEXPERIENCE and stored in a catalog. And then we'll be placing them in this particular car door, so where we would like them. Okay, and you can see it's just literally select the connector and click where you would like to place them. So you can, of course, later orientate it, and it's no different to handling any other type of CAD data in assembly. Okay, the only difference is there's electrical definition in the background. So once we've placed all our connectors, so we've placed a few here, what we would then do is essentially route a harness. Don't forget, these harness at the moment, it is a bundle. So let's say there's 50 wires going from one connector to maybe 10 wires to another connector. We're currently just saying there's a route between connector A to connector B. So we're not interested in the pin information at this point. So we can see here on the screen that we're creating branches from the main harness to create connections from connectors to connectors. And because we've electrified component, we don't need to define where we need to create the harness from. We literally just click on the connector and it knows where the bundle needs to terminate. And we can on the fly create branches off our existing main bundle route. Okay. We can define the size of a bundle route, and we can change the section type, so we don't need to be restricted to circular profile types. Okay. And we have various different ways that we can handle how that harness goes through from A to B as well. So we can use what we call the robot in 3DEXPERIENCE to manipulate the position. Now, once we have that nicely defined, so in this particular example, we have all the connectors all connected. We may add protective sleeving, and we can use protective sleeving that we've initially defined and stored in our catalog as well. So once we have it all nicely laid out how we wanted, we've got around all the obstacles around, in this particular case, the car door. We would take our pin-to-pin information and our wire information from the schematic. So that would particularly say, let's say we had a 50-pin connector that communicates 10 of those pins go to connector B and the other 40 go to connector C. And then we're able to tell it which route they will take. Now, if you don't use the likes of 3DEXPERIENCE schematic designer, it still has ECAD integration with the likes of Zuken, especially the E3 series. So you can take the schematic information out of Zuken and use that directly in 3DEXPERIENCE. Now, what tends to happen is you would reuse that and take bundle lengths, and you can take the bundle lengths out of 3DEXPERIENCE and back into Zuken as well. It depends where you want to create your manufacturing drawings, but you can now do it all straight from 3DEXPERIENCE. So in this particular example, now I've got my harness. What I'll be doing is actually adding an electrical physical system. So actually telling it what pin information, what pin from what connector goes to which pin on another connector via which route. So this information is stored in something called a EPS, electrical physical system, and it can be associated to one or more electrical geometries. Okay. So electrical geometry would be your individual electrical assembly, but with larger harnesses, you may want to break these down into more manageable electrical geometries, so smaller assemblies. But you can link these all together by a single electrical physical system. Okay. Now in 3DEXPERIENCE, you can create conductors, as they're called, so individual wires on the fly. So what we're doing here is we're telling it, we're creating a wire from a termination, so a pin number on connector A to a pin number on connector B. So this is the manual approach, and we're not doing this using the schematical output from 3DEXPERIENCE or the output from an ECAD solution. Okay, so typically this isn't the most common approach, but it is now possible in 3DEXPERIENCE to create your conductors. Okay. The most common approach will be to use the schematic from 3DEXPERIENCE or the ECAD solution. So in this particular case, we're using an output from Zuken, and we are basically defining the information. We're basically mapping the information from Zuken onto what we've got in our 3D. So from the output of a XML file in IXF format. Now, what you can see on screen, it knows which connector, so which wire goes from which connector to which connector. So it's literally in a straight line. But from a click of a button, 3DEXPERIENCE can automatically route those. And depending on the size of the wires, it'll automatically update the size of our harness as well. Okay, so it's all automatic. All we're interested in as electrical designers is where things are placed and how the wires are routed between them. We just take the schematic, map all the information to our 3D, press update, and it updates the sizing and the routing. So once we have that defined, the next step we want to think about is how we want to manufacture the harness. So what we would tend to do is flatten the harness for formal design or manufacturing drawings. So here's our harness, so one we've done earlier in our car door. We can see that all the thicknesses depends on how many wires are going through the bundle at that point. And typically, as you get to smaller connectors, the bundle size will reduce. And what we're going to do is use the form board tool and flatten that particular harness. So in this case, you have a single backbone, which 3DEXPERIENCE automatically detects by the largest bundle segment size, and it creates branches from there, and it flattens the whole thing. What we can then do is manage how it looks flattened. So we can then control the angle of, we can control junctions, change the angle of how something is displayed, and for large straight sections, which we might struggle to fit on a drawing, we can actually reduce the size of it as well. Okay. Now this is fully interactive, so once we've actually created a flattened harness and manipulated the view to how we want it to look, okay, it does automatically synchronize with the 3D. So if you make a change in the 3D later on, it does automatically synchronize to your flattened view. So you don't have to redo your harness flattened view again. Okay, so you can get ahead of yourself, create a flatten view. If you add a connector, it will automatically synchronize. You add components and it'll synchronize. Now, one of the advantages of using the 3DEXPERIENCE CATIA drafting app is that you can use something called a generative view style. So you can create a template. So what we've done here is we've spent a bit of time configuring our electrical generative view style template. And upon importing a harness view, it automatically annotates our drawing. So we've got our table of pin-to-pin information. We'll have bundle length sizes. We'll have connector pin information tables at the upon each connector. And of course, just like the flattened view, everything is fully synchronized as well. So if we go back to the CAD, everything will update. So as you make a change, it goes from the 3D to the flattened view to the drawing. And from here, we can automatically label any supports, any protective coverings, and you can see we've got all our bundle lengths, etc., defined on the sheet. So all we need to do is basically arrange the drawing to how we want it to look best. Now, that's typically an end-to-end process of how you would use the 3DEXPERIENCE CATIA electrical apps available to you, but there are some more additional capabilities. So here, for example, we have the ability to create our printed circuit board designer. So this capability allows us to keep everything within 3DEXPERIENCE. So some of the highlights is the creation of mechanical shapes of printed boards. It can automatically be reused in other CAD applications. Okay. You can place all these electrical components on the circuit board itself, and there are bi-directional interface with electrical CAD systems. So based on industry standard interface of the IDF format and IDX formats. And then the synchronization to other ECAD solutions are bi-directional as well. And then the advantage of basically bringing your circuit board design into 3DEXPERIENCE is that you maximize the capability of the platform and have all the information in one place. Okay, so you can all work collaboratively. It does also have other integrations with other circuit board design packages such as Altium Designer and Cadence Allegro. Okay. So the sort of benefits of having the ability to integrate Altium Designer with 3DEXPERIENCE or Cadence Allegro with 3DEXPERIENCE is that the integration allows you to store components directly in the 3DEXPERIENCE platform. So if you're still more comfortable working with these other packages, you can work natively in these other solutions, but still leverage the capability of a 3DEXPERIENCE platform by having the ability to store components in it and leverage other parts of that platform. So you can work collaboratively with other designers, other electrical designers, other systems designers or other structure designers, so anyone that's using the platform. It helps eliminate errors. So because everything's within the 3DEXPERIENCE platform, so a single source of truth, there's a reduction of errors. And you can make better decisions. So because everyone's come into one place to find the information, it allows designers to make better informed choices. Okay. So let's say if a designer takes information from an Altium designer and use it in their 3DEXPERIENCE, they can see the changes without having to have Altium as well. Okay. And the main benefit is it reduces cycle time. So the aim of the game is we want to reduce the time it takes us from our preliminary conceptual design stage to the end product and manufacturing. Okay. So that's me done.
So yeah, my name is Thomas Kislén. I'll talk about some electromagnetic simulation with CST Studio Suite, and also connect to some of the parts that Amit talked about earlier on the wire harness, and so on. So what about EM simulation? What is that actually? So for me, it's really of understanding things, that you can visualize all kinds of electromagnetic phenomena, that when you start to see and understand what's happening, then it's a way to do something about the problems that you get. And you can do that even before you have the prototypes or the real parts, actually. So the hot EM topics in the automotive industry today, where our customer use CST for development and optimization, it's really within a lot of areas like antennas and antenna placements, the sensors, all the sensors that you have, it can be simulated, and also understanding on how to improve them. Of course, the electric drive, the powertrain and the battery is a huge part of the development today. Control modules, entertainment system, cable harness, and many more. So these applications, they span for a large area regarding the frequency and in size itself, or in other words, it's when electrical size and bandwidth. So let's say that many sensors, they act or at or close to the DC points, whereas the radar system, you have to use the up to gigahertz range. Typical structures on the PCB are just some millimeters long, and the dimensions of the vehicle itself, it's meters. And you also seen that the cable harness is kilometers. So it's really spans from a wide range, and you would need a powerful simulation to cover all that with different solver technologies and meshing abilities. And CST, it provides easy, efficient, comprehensive development for those products. New generation of vehicles includes electronics in all areas. For instance, the ventilation system, electric motors, chassis, electronics. And the biggest interest is probably concerned with the power of the electric motors, and the high powers in the mind, it's high efficiency from the power electronics. So you have to also look at the thermal effects and the electrical noise from those motors. And of course, the size, weight, position, efficiency of the battery systems are also important. And I mean, there's a lot of changes going on at the moment, and simulation is key to doing the optimization. So CST as a simulation tool provide all possibilities to get answers to important questions early in the design phase. And that could be in connected vehicles or ADAS, AV sensors, electric drive, the signal integrity or power integrity, performance, wire harness, electrical engineering, and EMC and EMI performance. So let's take some examples, specific examples. For sure, you've already seen so-called shark fin antenna for phone and GPS navigation. Well, if you're developing those kind of things, questions that you need to answer is, how should it look like? What the size of it? How will the performance be when you have different sizes of it? And also, of course, the performance, where should I put it? Where does it work in the best way? Simulations can give you those answers already on the concept phase. And if I choose an antenna and I place it on the rooftop, yeah, it works here, but how about if I change to a different car model? Will it still work in that position? It's easy to just change the position and see the installed performance. And on ADAS, AV sensor performance, of course, it's those advanced driver assistance systems they're developed to enhance the systems for safety and better driving, and designed to avoid collisions and accidents. And obviously it's really important that in those advanced driver assistance systems and autonomous vehicles, it requires that you know the dynamic changes in the surroundings all the time. So you need to have good connections, and you need to collect all the information to the vehicle to make the right decisions. So the simulations can help with that. And if we take radar as an example, you would need to know about the radar sensor. Is it performing? Does it still work if you have ice or snow in front of it, or dirt? And what is the optimal positioning of the radar? Should it be behind the bumper, or where on the bumper should it be placed? And also you need to identify objects with the radar in front of you. Is it a car, as you see in this picture? Yeah, it's a car. It's quite easy to understand it. But what about the lamppost, or a pedestrian, or even a large animal like a moose or something like that? How do you identify that, and how do you optimize your sensors to recognize those things? So this is answers that you can get with a good radar development and simulations. If you go into the next section about the electric drive and the powertrain, so analysis of electric drivetrain includes the batteries, it includes the inverters and the electric machines inside the car body. So typically, the following questions come up with electric drive. It's which is the best battery concept, and for instance, and how much space is required for the battery. Could also be, how can we improve the power and efficiency of the electric motors? And the important thing is to have this combined in one complete tool, where you can cover all this the wide range of things that comes up. Amit showed us earlier about the wire harness and how we can design that, but what happens really when you use it? How does it look like? About like this charging situation, the cable wiring, if you place it in one place, will it work, or will it affect other parts or humans, for instance? Those things we need to look at with the electromagnetic simulations. And also shield cables. Do we need it or not? It's really expensive, so you would make sure that you only use the shielding if it's necessary. And of course, if it is necessary, how to design that as well. And maybe the most important ones, how can we reduce the vehicle weight and the cost for labor to do it? And in this case, with simulations, we can simulate the wire harness to look at hot spots where not to place cables, because the cables themselves, they will act like antennas, and even if you don't want them to. So sure, you would like to simulate to make sure that it doesn't affect other systems. And all electronic devices, they have to comply with legal regulations, and therefore you have to make sure that the EMC and the EMI, the electromagnetic compatibility and the interference, you need to check that. Always check it in a verification test in the end. But when you come to the test, when you have prototypes, you're very late in the design phase and you're ready to go to the market. And if you fail there, of course, that will imply a huge cost. And normally, many components comes together in a complete system like a car, and the components themselves, they have been EMC tested, but when they come together in a complete system, will it work in that case as well? You have to check that, and for sure to do that in an early phase. There could be questions like how powerful is the wireless charging? will that affect the car itself or the other electronic components, or will it be harmful for human exposures? Those kind of questions you need to check as well. And I mean, it's impossible to test it on humans, so you need simulations to know the rates that you comply with the regulations. So getting the design right at first time is crucial for product developments, and virtual prototyping electromagnetic simulations can help you to reduce the design iteration cycles. And also related to this, the smart testing enable optimal combination of simulation and physical test that reduce the overall cost for your development. And finally, you can improve the quality. You can optimize and look at even more variants and doing more innovative designs if you have the possibility to understand and see how it looks like in the beginning to run the complete development. So some key takeaways from this. For sure, electronics is transforming automotive industry today, and due to high complexity and the sheer number of electronic parts in the system, EM simulation is the key to the entire development process to know if it works before you have produced it. And CST provides the complete technology for all kinds of EM applications that you will face. And to end with is that the main drivers of the innovations is electric, connected, and autonomous. And with that, I would like to say thank you. And questions on this section or the earlier from Johannes and Amit, you can place that in the chat here on the side, and we can try to answer them, all of them.